Yeah, we're really excited today. Thank you again for joining us, Ofer. We've got Ofer from Vectara. We're going to go through some topics around Vectara-agentic, which is a new package they've released around agentic RAG. And I won't take too much from there because I know I was going to talk a lot more about the details within that. But we have an integration that we've created between Vectara-agentic and Phoenix. So we'll touch a little bit on that, but spend a lot of time just going through agentic RAG, what that is, how you can use it, how Vectara helps with that side of things. And I think that the package they released is really cool. So I'm excited to have us be able to go through some of that. And yeah, we can just start with a little intros and then I'll let Ofer drive from there. So just from my side, I think folks who've been on some of our previous webinars may have seen me before, but I work on kind of our generative growth for the Arize side. So a lot of developer advocacy that we're doing around that, basically trying to figure out how we can continue improving the generative product that we have, whether it's Phoenix or Arize, bringing and get as many people seeing that and using that and growing with that as possible. So I get to represent a lot of the developer ecosystem internally as well. So functionally, it looks like a lot of events and a lot of content, which is really fun for me to do. Previous life, I had worked at a mobile ad measurement company called Branch, and then done a couple stints. I did my VC stint for a minute just to see what that would world look like, and then moved back to the AI side. But yeah, so that's from my side. Ofer, I'll let you introduce yourself as well, and then you can kind of take us from there and continue on.
Thank you, John. Glad to be here. A little bit about myself. I also run developer relations at Vectara. Been a machine learning engineer, software engineer for many years at different companies in the Bay Area. And one of the things I got, I think of it as lucky, was I got introduced to kind of this LLM technology kind of early on, around 2019. So I used GPT when it just transitioned from like V1 to V2. So I had the opportunity to see kind of this space evolve into what it is today, and it's truly amazing. So get into it a little bit about Vectara. We're a company headquartered in the Bay Area in Palo Alto. You can see a little bit of details about us and some of our customers, but generally what we are is we are a Gen AI platform that gives organizations a way to rapidly create trustworthy AI assistants and agents grounded in data, which is kind of RAG, which we'll talk about. So what we do is, I think this is a great slide to show what we do. So if you build a RAG pipeline on your own, you know that there's a bunch of components you have to build yourself. You have to build extraction of data, encoding, indexing, retrieval, vector database, a bunch of things inside. And we've built all of those components in our platform. And as a user, then all you have to do is use our API, which kind of wraps around this. You have an API as a builder, as a developer, you can use the API to upload documents or upload text that you want to use for your RAG pipeline. Or when you integrate it in some kind of user interface, you would then ask questions using the query API. So that's really kind of a high level of what we do. Now, before I jump into this, I want to just set up the basics. I'm sure most people heard about RAG, but just kind of my view of what it is and a kind of quick explanation of it is RAG stands for Retrieval-Augmented Generation. And it's a way to use kind of LLMs with your own data, right? And so in a regular LLM flow, you ask a question of, let's say, ChatGPT or Gemini or whatever, Anthropic, what have you, and it just sends the query to the LLM and gives you a response based on its training set, what it's been trained on. In RAG, the query goes kind of to another data store where you have all of the data that could be your private data or something that you want to point it at. And then a retrieval engine essentially picks up the most relevant pieces of information or chunks of text that are relevant to answer this question. And you essentially tell the LLM, please answer this question, but ground it on this information I provided. So it's a kind of a retrieval first system that augments the knowledge of the LLM with some of your own data. So this is what RAG is. It helps reduce hallucinations because you get to ground it on information that you know is relevant for the query. Your data, of course, remains private. So this is a question I get asked a lot. There's no training involved. There's no fine-tuning or training. Your data just is, it's like putting a search engine on top of it. It's not, there's no, data doesn't get lost in the weights of any model or anything like that. And as I'll show you in the demo, you also the ability to have citations, which provides explainability. So the citations show you where the LM took the information from, which again doesn't exist in the regular kind of pure LLM space, which helps a lot to build user trust. So that's kind of what RAG is. This is a little bit of a detailed, kind of more technical picture of what happens inside the box, right? So when you build a RAG pipeline, you have two main flows. The first one is the indexing, where you essentially take data from wherever it is. It could be some apps like Notion or Salesforce or Jira or something like that, or even files on S3 or some database or what have you. And you can ingest this data with some metadata. And then what happens, you have to extract the text from, if it's a file like a PDF, you have to decide on how you chunk text if it's too long into smaller pieces. Then you run something called the embedding model, which encodes it into a vector representation and puts it in something called a vector database. Many of you have probably heard about this. And then uh, when you do a query, you similarly take the query, you encode the query text as well into a vector, then you kind of do similarity search against the vector database. Sometimes you also apply what's called a re-ranker that gives you even more relevance. Construct a prompt for RAG and say, hey, LLM, please generate a response to this query given these results, these facts that I pulled out of this process. And lastly, there's something called HHEM that we have created. I'll talk about it later, but it's a hallucination detection model. So you can take the response and determine whether it seems like could be a hallucination, and then maybe you can show that score to the user to give them information about whether it's potentially a hallucination or not, or even you can just remove it if it's really low and really seems like a hallucination, and then you send a response back. So there's a little bit more details in that, but I wanted to give you a kind of a deep enough but not too deep kind of view. And one thing that you can think about for Vectara is instead of building all these pieces yourself, which is actually pretty complex, especially when you go to enterprise scale, we build this as RAG as a service or RAG in a box, which means that our platform has all these pieces together, humming well, optimized, tuned together. You don't have to build them, you don't have to maintain them. You just have to use our APIs to index and to query, and everything else we take care of for you. So you don't have to become a RAG expert in a way. And that's really kind of a lot of what Vectara is all about. So let me show you a quick demo. This is a question answering demo that we built. Again, we're a developer platform, so we don't, you will build a system like this if you use Vectara for this. But this is a UI that showcases an example. So we decided to build this to point to use it on top of data that is from different news sources. So in this case, these different news sources, right? And so we crawl these news sources every day, and we ingest it into Vectara using our indexing API. And then you can start asking questions. So you can say, should artificial intelligence be regulated? Now it goes and runs a query underneath the covers with the API and shows you, first of all, the generative response, which is kind of what you're primarily looking for. But then, as you can see, I talked about citations. You can see the citations, see the references. So you can sort of click on this, see this result, and say, okay, I have some notion of where this was taken for, why it's relevant. You can even click on this and go see where it came from, like that, etc. And then you see here this HHEM, this factual consistency score that gives you a sense that this response, based on this information was retrieved, is a high confidence, which means it's not likely to be a hallucination, right? So this is how this HHEM works. Okay, so that's what RAG is. This is our promise. We want to talk about agentic RAG a little bit today. So I'm gonna go to that. I just want to highlight one more thing, which hopefully will be helpful to people on the session today, is uh, a lot of people are transitioning. They're either learning about RAG, but if they've experimented with this a little bit, they move from a POC to an enterprise deployment. We see that quite a bit around. So I wanted to share some nuggets of things considerations that I feel are important and the challenges some people see when they do that, right? So the first thing is trust, right? Trust in the quality of the response. And so as I've shown you, citations do create a lot of trust for the end user of your application because they see where this thing is taken from. They can even further investigate it if they want to. And the ability to detect and reduce hallucinations also creates a lot of trust. So this is a quality of the response is probably number one priority for everybody. You got to trust the results you have, especially in an enterprise sort of use case. There's of course security and privacy considerations. You want to make sure that you have all the box checked. These are kind of table stakes requirements we need to deploy in an enterprise. Um, uh, Scale is an important piece when you move from a POC of 5 or 50 or 100 documents to a million documents. Things change. It's harder to get things to respond quickly. Accuracy sometimes gets reduced. So you got to be a real expert to know how to tune your, if you build it yourself, how to tune sort of these pieces together. And that's again one of the benefits of Vectara is we do that all for you. So we tune everything to make sure that you don't suffer as you scale from 1 to 1,000 to 1,000,000. It's kind of all the same. I mentioned a little bit about quality of results, but I wanted to touch on retrieval accuracy. So RAG is retrieval augmented generation. The R is really important. And adding a lot of different capabilities in retrieval ends up being super important for the quality as well. For example, imagine that you have your data, like I showed in the previous slide, and you have, I don't know, 10 documents. So the number of documents or number of chunks of documents or text that might be relevant for a particular query is probably pretty low. So it's very likely you're going to get most of the right information into your LLM when you run RAG. When you have 1,000,000 documents, there might be a lot more quote unquote competition for this. And so it's really important to make sure that you have the best retrieval engine, full stop to get the best results. Guardrails, I didn't have it in my diagram, but a lot of times you have another piece there, which is guardrails to make sure that the response complies with company policy and things like this. And then, Vectara platform, of course, works as a SaaS product, but that requires you to send your data to us. But we'll also have an option to install it within your environment on your VPC or on AWS or GCP or whatever, and even on premise. So those deployment options are very, very valuable. And then, of course, the other thing that people struggle with is, okay, I built the initial application, but who's going to provide this production support for me? And it gets complicated because if you go and take your own vector database and your own piece there and embedding model this, at some point something goes wrong, and how do you know what went wrong and how to fix it? It becomes really complex. So that's my kind of 2 cents about kind of things to be cautious about when you transition from your kind of POC to enterprise deployment. And I mentioned HHE. Yeah.
Do you mind if I jump in on the last one? Because we had a couple of questions
Yeah,
around
please.
some of the deployment and security and some of those things there too. So
Of course.
we had one question that was when we ingest documents using the API, if Vectara has access to that uploaded data, how does that work with privacy? Seems like the virtual private cloud and on-prem may address that.
Correct.
And then there's another question as well too that's just around like you're sending data to Vectara. How does it work when it's an on-prem deployment in terms of like what data Vectara is given access to? Does anything get sent to Vectara separately, or is it entirely on-prem in that case?
Yeah, so first of all, let me add one more thing about the security and privacy with the VPC, which is, yes, the VPC one solution there, but also our kind of SaaS offering is also like SOC 2 Type 2 compliant and HIPAA compliant and GDPR. So all these are also there, but of course the VPC is the kind of the ultimate way to do it. When you go to on-prem, it's of course a little bit more complicated and depends on your setting and your data center environment. But generally, it could be, again, completely airtight. Nothing goes back into anywhere, right? And I'll talk about Mockingbird, which is our LLM, again, that helps with that and how that works. Actually, I probably should talk about it now. So I showed a lot of the different pieces here in this slide. The generative LLM could be an LLM that you want to call on your own VPC, right? It could be hosted anywhere in your VPC and you could do it. We can also call the regular LMs that you might want to call OpenAI or whatever. But we also have an LM that we really recently announced called Mockingbird. And Mockingbird is something that really runs truly just on your machine in your environment. And it's something that makes sure that nothing kind of gets out of the environment. So it's really like a sealed box um, on the VPC. And on-prem, again, on-prem, the only difference is that we have to figure out what the boxes are and make sure that your data center supports. Some of these things require maybe a GPU to run, and that's where it makes it a little bit more complicated because the cloud environment is not necessarily given the way it's given in other places. So hopefully that answers that question. Anything else, John, there on the question?
I guess there was one other one as well too, because folks were trying some different inputs into the demo that you shared earlier on. And there was like some things that were like the current weather today, for example, doesn't crop up. And so I guess there's a question that raises to me, which is in these kinds of systems, do you often see companies restricting the types of inputs that the RAG powered system would actually, or sorry, restricting the outputs that it would give in some of those cases to not include things that are not represented within the RAG corpus that you have? Or do you typically see them leaving it more open-ended?
So I see a little bit of both. It's a great question. I think, look, if you pointed at a news and you ask about the weather, you don't expect it to give you an answer. So usually, for example, in our system, the most common thing customers want to do is to say, just respond with, I don't know, or I don't have the answer to that. But you can, of course, customize it to do something else. And I'll talk about agentic RAG, where you can actually have a little more flexibility in a little bit to also have access to additional sources of information to complement the answer. And that's another way to solve that problem. So before I go to Vectara-agentic, I just want to mention one more thing. I mentioned HHEM. It's actually a really interesting model that we've developed, and we found it so useful that we actually decided to open the weights. So it's available on Hugging Face. You can see it here. HHEM is a model that takes your facts from your RAG pipeline and your summary and tells you whether that summary is a hallucination or not based on those facts. So even with RAG, you can still give it facts, and depending on the LMUs, it might still make a mistake. So you kind of want to know if the final response is a hallucination or not. And HHEM does exactly that. Now, there are other ways to do it. The other approach I've seen in other people try is this thing called LLM as a judge. So in other words, you take the same information and the response, and you ask an LLM to say if it's a hallucination or not. But kind of putting my scientist hat on, one, I have some suspicion of whether that's kind of okay to do, right? Because you ask LLM to judge an LLM. But also, beside that, on a practical level, HHEM is very fast and very cheap. If you use our platform, it's automatically provided. If you use the open source, it's not a very expensive model to run. You can run it locally too if you want. It doesn't require like a big GPU and a lot of resources to run. You don't have to pay a lot of money in tokens to some LLM providers. So it's a very, very effective type of model. What you see here in this graph is we also have a leaderboard where we judge by HHEM the likelihood of different sort of models. There's just a few shown here. The top models, and we keep updating this as new models come in, and how likely they are to hallucinate, given we just measure them on a kind of a hidden data set and then show the results of how many times they hallucinated. So very popular thing as well. So all right, we arrived at Agentic RAG and Vectara-agentic. So really excited to talk to everybody about this today. And I will explain what it is, but kind of to give background, I also want to emphasize at the end why even in this kind of emerging field of agentic RAG, reducing hallucination matters even more, right? So that's one of the key points I'm going to tie back from the HHEM and hallucinations, right? So this is generally what agentic RAG looks like. It's my version of the diagram, but think about it as a user query coming in here. And then we have, typically you call it an agent, but it's the brain of the agent or the assistant. It's sort of like really is controlled by a large language model, okay? And it's something they call a tool use large language model, which has a certain type of capabilities to, you guessed it, use tools. And so you provide it when you build one of these agents or assistants, you give it a number of tools. Some of the tools could be a RAG tool. I'm sorry, it should be RAG tool 2 here. So these will be different tools, it'll be Vectara RAG 1, Vectara RAG 2. So you can give it one or more tools to call Vectara to get a response. But you can also give it a tool that just calls some API, like I don't know, maybe a paywall call to Crunchbase or LexisNexis or something like this. Or you can even call a database and do a SQL query with it, which actually I'll show you in a little bit, or any type of function that you really want. And what happens is that when you get the user query in, there's some reasoning step where the agent LLM here sort of understands the query and decides what tools to call and in what order. And sometimes we'll call this one and maybe tool 3, it'll get the responses from each, and it'll sort of, take all this information together and craft a response that will be sent back to the user. So this is a very powerful kind of emerging extension of RAG because it allows you to add some real-time information, other information sources to augment, not just by the retrieval piece, but also to augment with other information that you have in different forms. Vectara-agentic is simply a open source Python package. You can look at the source code. You can just install it as well if you like, with pip install. And essentially, it provides a very easy to use framework to build these types of assistants and agents. And I'm showing here a little bit of code, which is the simplest way to use it. There's other ways if you have more than one tool, but this is a simple way of just wrapping one RAG tool with Vectara around with an agent. So this case, you give it the Vectara, your customer ID, your corpus ID, your API key, and you give a little bit of descriptions of what you want to have the tool do. And it essentially builds a tool that is called, in this case, Ask Medicare, connects to your corpus of Vectara here, and will just be, to your question earlier, John, will be kind of responsive even outside of the corpus if it finds a good way to answer to those things. So that's what Vectara-agentic is, and I will encourage you to play with it and see. It's really, really powerful. I want to show you one quick cool demo that I really like to show. So this is a demo about electrical vehicles. So we created two Vectara corpora here. One that has information about electrical vehicles, and one that has information about regulations and laws around electric vehicles, but also added a local database with information from the state of Washington around registrations and like a regular tabular like CSV file about this. And what I wanted to show you is this cool thing. So imagine I ask this complicated, multi-step question of it, right? So if I ask this, the engine will now work. And what happens in the background, and what I want to show you is what happens at the end, if the demo guys are going to be with me here, is that what I wanted to do is to kind of answer both parts of this question. And it actually will use different tools to do that because okay, this was pretty fast. Good, okay. So let's see what happened. It gave me an answer to there's battery BEVs and there's hybrid PHEVs and explanation of both. And it also gave me the second part of the question, which was how many registered in Washington. So it gave me some numbers around that and even some references. But what I wanted to show you is the logs here, which what's happening underneath the covers, right? So what happened is he got this question and he decided to call Vectara tool here with the query this part. He took this part of the query and used that to query Vectara from the original user question. It got the response here, got some references. Then it said, the other one, I kind of need the database. So I'm going to list the tables. So I got 3 tables that is provided. So the assistant here doesn't know what's in the data at all. So first it lists the tables. Then it asks to describe the table it actually needs. It understands that the registration is the one it actually needs because it's about registrations. So then you get a kind of a description of all the fields. And then it loads a sample of the data set to kind of get a sense of what values are in there. And then, and this is the cool thing for me, I really get excited to show is it actually crafted a whole SQL query on its own to answer the question I asked it, completely kind of on its own with the end and the group by and everything that's in there. And then got the response. And then the agent took all this information from Vectara, from this query and everything together and kind of crafted together this response for the user. So I love this to show this demo because I think it shows the power of Agentic and how powerful it could be to really, really answer user questions in the most powerful way. So okay, I'll give it a thumbs up, this one.
Oh, can I ask with the
And yeah,
thumbs up? Are you guys incorporating the like the thumbs up and thumbs down into that as well too? Does that get the share back?
so again, we're a platform for developers to build. So this is something that's in this particular UI.
Got
We don't do anything with it, but it's a good question. We do have something we recently launched called UDF Re-Ranker.
it. Mhm.
I didn't mention it earlier, but it's a type of a ranker you can chain a couple of rankers together, and that's a good use case for that. So you can sort of like collect all of these, and if you decide you want to use it, you can ask the UDF ranker to rank higher things, better, higher in the result set and take advantage of this data. So we don't do this automatically because it depends on what you want to do and what your use case is. But yeah, it's a a good way to do that.
Nice. Makes sense.
Okay,
Um,
so sorry, and so that was my demo, and I'll pass it over now to you, John, to talk
yeah,
about the Phoenix iteration.
definitely. I think before we get to that, there's a couple of questions. I see again people kind of tossing in different
Okay.
inputs into the demo, which is always a fun thing of giving people the demo as we go through. So just to make sure I've got it right, I think there's some people who've tried other questions that have to do with other regions beyond the kind of corpus that you pulled in. So we got people trying like Manhattan as an example, and then some folks who are trying like kind of completely different queries. Like we have a great one of give me info on Elon Musk, for example, and it's coming back with I don't know. That's all kind of
Yeah,
expected, right? Those are all the results you would
absolutely.
expect
We
to see.
we only included CSV data for Washington State
Mhm.
just to make this the demo simple. And yeah, it's just information about EVs, not from the Tesla website. It's from the EPA and like admons.com or something. So I don't think it will have information about Elon.
Yeah.
But again, this is one where a bigger demo you can build, you can put whatever you want there. And if it has that information, it will answer the question. The I don't know is actually a good answer because you
Mhm.
wanted to say, you don't want to hallucinate. You wanted to answer, say, I don't know. And
Yeah.
as a builder of an app, you can say, oh, maybe I should add this other source of data and add this information. This is useful for your use case. Yeah.
Mhm. Got it. And so actually there's a question too of like how do we don't know what our users are going to put in, so how do we kind of control what they're going to prompt? Is that I don't know piece is sort of configurable as well too in a way. I think you have some pieces there or is that sort of the default response? I guess how do
Yeah,
you customize
you
what you come back with?
you can configure that both at the agent level and also on the Vectara rag level with custom prompts. So you can definitely configure that.
Mhm. Got it.
Yeah.
Yeah, that makes sense. Cool. Yeah, I see some of the chats in there. So let us know if that doesn't answer your questions as well too, guys, because I think there's the piece of designing the user experience around okay, this is what the information the agent has access to and making that clear to the user. And then there's some customizability too around like what should it do if it doesn't have the answer within the setup. Um,
Correct.
yeah,
And we'll answer some more questions maybe at the end. So
yeah,
maybe
yeah,
we
totally. I
keep
can jump into
going
the
on the
Phoenix
slides and we'll
piece.
answer all the questions at the end if that's okay.
Yeah.
So go ahead, John.
Yeah, so just the other piece of this is that one of the things we wanted to do is we've created this integration with Phoenix where we can send in some of the trace information that's created through the Vectara-agentic package. So for anyone who doesn't know, I think some folks are more on kind of the Arize side, and then we also have our open source product, Phoenix. So Phoenix is kind of an open source version of some of the capabilities within the Arize enterprise platform, including tracing and including evaluations. So it allows you to capture evaluations and tracing for LLM applications. The way that it typically works is you've got a instrumentation happening in your application, and that's the part that's been kind of automated with this integration, which tells you what calls and what API, what methods to kind of capture information on. And then those will get sent over into a Phoenix instance here. There's a bunch of ways to run Phoenix. It's either self-hosted or there's an online cloud instance that you can access as well too for free. And so both of those are supported in this integration, and you can end up with views that look like what you see on the right side here, where we have LLM calls being traced, retriever steps being traced, all of these different pieces, all of those different kind of boxes within Over's original diagram that we went through get represented within the spans and traces that we see. So if you want to go to the next slide here, the integration makes it really easy to do this, which is awesome. And huge shout out to Over and team for helping set this up as well too. This is really a pretty sleek one. So the way that this is all set up is you have a step one, which is just launching Phoenix. Again, you can do that locally with this sort of Phoenix serve command that we have within our Python package to run like a truly local version in your terminal, or through Docker. Or you can access a cloud version online. That's also free to use up to a certain limit of traces. At app.phoenix.arize.com, you can kind of create your own cloud instance, which gives you an API key that you can access. So depending on, I know there's a lot of questions around like security insides of that too. So depending on where you fall on that side, you can always do the self-hosting version versus accessing the cloud. And then once you have that up and running, then you can connect your app to that Phoenix instance. So in your code, you would just first off set this environment variable, this Vectara-agentic observer type as Arize Phoenix. That's what kind of triggers the integration, sets up all the tracing and instrumentation for it to capture all the right calls that are going to be made by Vectara-agentic. And then depending on how you're hosting Phoenix, there's a couple other environment variables you might add. One that specifies the endpoint that we're sending traces to. So if you're self-hosting on a specific endpoint, you would add that there. If you're accessing our cloud instance, then you would have the one we have here. And then if you're accessing the cloud one, then there's an API key that gets involved with that as well too. So these are all environment variables that are used within the rest of the scope of Phoenix outside of Vectara-agentic as well too. So those should look familiar to anyone who's played with Phoenix. And I'll say too that this integration can work for the Arize side as well too. So if we have any enterprise users who are using the full Arize enterprise platform, we can also use a similar setup here to send that information through into the Arize platform. There's just a few different environment variables that get used for that. So it does work across both Phoenix and the Arize side, which is pretty cool. And if you want to go to the next slide, what this looks like in practice is this is just an example of a kind of expanded trace. So you can see, actually, I think it's from the same demo that you were showing before, the EV one. So you can see some of the steps that get run as the agent will kind of chat, it will create tasks, it will run steps, it kind of goes through and it goes through these different stages here. And so we expanded those further, we could see the retrieval step that's happening, the LLM generation step, all of those pieces there. And then one other thing that's very cool too is that we've also added in the Vectara FCS, which is the factual consistency score, if I have that right, which is a metric that Vectara is sort of calculating on how correct and factual the response is, or the likelihood that the response is entirely factual. That gets added on automatically with this integration, as well as just an evaluation within the platform. I don't know if there's any more you want to add around that particular score.
Yeah, just FCS is just our name for HHEM. So HHEM is sort of maybe the publicly available. And the only difference is that the open source one is English only, and FCS is slightly better and supports multiple languages. But yeah, this is, I love this visibility it gives you about the agents and what to do, and especially the integration with the FCS is really cool.
But yeah, so super easy to set up and use. And again, credit to the Vectara team for pushing forward this integration as well too. It was a really smooth one to set up.
Yeah.
Awesome. We have a couple other questions as well too that maybe we want to tick through. We got one in here that is from Greg around how do you handle really complex documents within Vectara? So like heavily styled PDFs or kind of more unstructured data like that. So I don't know if there's anything you can speak to there.
Yeah, it's a great question. So a lot of times, PDFs might have like tables or diagrams or things like this. And currently there's two ways. There's one which is we deal with that pretty well in the platform today. Like you can upload PDFs and we'll process them pretty well. We're working on some improvements that we can announce soon that will do even better than that. But there's also an option of there's a project, open source project that we created called Vectara Ingest, which helps you ingest data into Vectara quite easily. And one of the features there is the ability to do a better job of processing tables and diagrams and things like this. So if you enable it, it'll help you with that and give you a better outcome. Yeah, and so if you're interested, let me know and I'll share some of the links for that later on. It's a pretty useful project that helps you ingest data in general from different sources. But you don't have to use it. It's just kind of a helper. It's open source, so you can use it as reference or whatever you want to do.
That's very cool. And then there's another one we got as well too, which is what have been the most used types of agents that you've seen from your clients? So kind of what are
Ah,
folks using this for? Yeah.
so we also have this terminology we use kind of between agents and assistants. I know it's a little bit confusing because it's a kind of an emerging space. We think of assistants as things that give you answers, like I've shown you here, an EV assistant and a financial assistant. And agents are more ones that will actually take action on your behalf. So let's say they'll not show you the flights that are available, but actually book a flight for you, right? So it's a little bit of a higher level of, so to speak, risk, or you have to have a little more trust in your system to actually do that. Um, but in terms of types of agents, we see a lot of use for this Vectara-agentic package in general and agents in general. Um, the I don't know if I can tie it to a use case, but more to the capabilities of agents, right? So the capabilities that make it very powerful is the fact that you can access other sources of data that are not textual, like I've shown, like SQL databases or some APIs. That's really powerful. You can imagine, I'll give you one use case, for example, which is imagine you're in university, right? I'm here in Boston, so okay, maybe you're Tufts. This week I'm here in Boston for those who have not been in the early part of this session. So you're at Tufts Medical Center, let's say, or Tufts University, and you want to build something for your students. You can have a lot of stuff about what to do as a student, how to behave, how to get your classes organized. A lot of information that students want to have in sort of their assistant uh, or with RAG that's pretty fixed information. But you might want to also, in real time, have an API call going into the university systems to get who is your advisor and who is sort of what classes you're taking and what year you're at to really personalize the response to you. So that's one example of use case. It's pretty broad. You can imagine this in healthcare systems where you want to personalize to your medical record. You can imagine or get some information about the particular clinic you're in. You can imagine this in financial services where a wealth manager person talks to a customer and wants to know late information about that. So those are really, really useful use cases for that I just can think of right now.
That makes sense. And actually, this leads into another question that we got that actually works well too, which is the question is how do the agents themselves talk to each other, and how do you have situations where you are maybe aggregating? Are you sort of? I guess it's more about the architecture of the code. So let me just read the question because I don't want to butcher any of it. But do the agents talk to each other, and how do you control how much they talk? Or are you aggregating answers from all of the agents in parallel and then making the final LLM call to kind of summarize the concatenated answer?
So in a typical assistant or agent setting,
Mhm.
the most common way is the later one, which the agent calls the different tools and kind of kind of puts it all together and gives you a response. Let me talk a little bit about multi-agent though a little bit. And also I want to make a comment in this respect around hallucination. So agents are really cool. You see the level of excitement I had when I showed this demo of the EV. It's super powerful, but you have to be careful. It's still emerging. And I would say, you got to know what you're doing. You got to do it right. Um, it's not just pure magic. And if you hallucinate in a process of agentic RAG, it compounds because imagine you hallucinate in step one out of 5 steps, you're kind of toast because everything becomes bad. And so fighting hallucination and detecting and removing hallucinations is even more important to my previous point about HHEM than ever with this sort of new types of things. Now, multi-agents are super cool and because you can have multiple agents talk to each other. So the typical use case there is one that I think about is legal, right? So you have somebody wants to write a legal opinion. So you have an agent to write the opinion, and an agent to critique it from a lawyer perspective, an agent to critique it as a judge. And so you can have these different things. Um, and there's also the idea of agents talking to each other and sort of implementing each other as opposed to just step by step. All these are great. The caution I want to put in people listening is that you got to make sure that this will work. It's really emerging, and sometimes you're going to spend a lot of time, and it's just maybe too complicated for the technology right now. So you got to be careful and make sure that you do it right, and you make sure that it works for your use case. When it does, it's kind of like the EV assistant I showed. It's like magic. It's wonderful. It does really great things, but it's not always as easy as it looks. And kind of from a practical experience, I want to just highlight that.
Yeah, yeah, that makes sense. Some great points being raised in the chat too around techniques of reducing some hallucinations, whether that's chain of thought, citing sources, having sort of this reason act, which is almost in a way a sort of a self-critiquing aspect as well too, that you were mentioning with the legal side too. It's a sort of a variant there, I would say. So some great points being raised there. There's another question that we got as well too, which is whether there's any kind of common agentic framework being used under the hood, like a LangGraph or Crew, or if Vectara-agentic is entirely proprietary.
No, it's not. It's first of all, it's open source, so you can see exactly what it does if you like. But it's using actually the Llama Index agentic framework underneath the covers. So the idea of Vectara-agentic is to sort of make it easy to use with Vectara and make it kind of a higher level of abstraction than Llama Index. So if you want to write with Llama Index directly or with LangGraph or Crew or anything else, you could, but it takes a little bit more effort and a little bit more knowledge and know-how. And Vectara-agentic kind of abstracts a lot of the complexity out and makes it really easy to create, usable agents this way.
Awesome. Yeah. So using their workflows framework that they have as well, right?
Yeah. And
Got
they
it.
have also agentic specific components like reasoning engines and things like
like a
that.
React component, I think, right?
Yep.
Yeah. Awesome. I see some other points being raised around kind of security and having a robust access control system and roles to help reduce things like prompt attacks and things like that. I'm not sure if that necessarily it comes to the Vectara agentic side of things, but I guess is there anything like specific around security that you want to highlight with regard to Vectara agentic specifically? Because I know we talked around Vectara more generally as well.
Yeah, so I'll do for both Vectara and
Mhm.
Vectara-agentic together. I think the area of security, usually, let's unpack this. It's got a couple different pieces to it, right? The security of the system, right? You want to make sure that everything is encrypted everywhere in your data, like the typical like enterprise security sort of requirements. And of course, we do all of that. So we are SOC 2 Type 2 compliant. We have HIPAA compliance, GDPR, et cetera. So we have all those certifications you need. And again, those are I'm browsing through it quickly, but again, in an enterprise environment, it's not as easy to get that when you have 5 systems that you kind of stitch together, right? Sometimes it's more complicated than that. In terms of prompt attacks, again, because we are sort of a system that's RAG as a service, we protect in the prompts that we allow you to put in and have by default against a lot of prompt attacks. It's not open to anybody. It's something that is very protected against prompt attacks in that sense. And then the other thing I wanted to mention about security, which is really interesting, is about access control, right? So this is something that people sometimes miss, and I want to highlight this point very clearly. Is so in RAG, sometimes again in an enterprise environment, you might have, let's imagine a simple case where you just have your Google Drive and you have a bunch of documents there, and you want to just ask questions about those, right? Usually it's more sources, but just to simplify, let's assume that. So some of these files might be protected with permissions only for the CEO or only for the HR department to see. And you don't want to make sure that you don't allow a response because you ingest the data in, and you want to make sure that you protect against the fact that only the CEO can see responses that include information from documents that only the CEO can see, et cetera, right? So our ability to have very strong filtering and metadata allows a really robust implementation of that to allow you to make sure that inquiry time, when the facts come in, based on who you are and what your role is in the organization, you will then be able to only craft responses, or the RAG system will craft responses only based on information you're allowed to see.
Interesting. That's a very cool,
Yeah.
very cool feature, like RBAC around docs themselves in a way, or information themselves. That's very cool.
Yeah. Yeah.
Awesome. Well, I think we've covered all the questions that came through. I want to say another big thank you to Ofer here as well for joining us. One quick plug as well too from our side before I'll let you close it out, Ofer, afterwards. We are going to continue with we recently wrapped up a whole series on agents. So there's a bunch of material on our site for that. And we're actually going to be kicking off another one come, I think 10/29 is the first date for that. So we'll drop a link for that in the chat, but we're going to start going through a lot of real world examples of agents, kind of decomposing them and everything there. If you're curious to learn more about agents, definitely check that out. But again, Ofer, thank you very much for joining us. I'll let you close it out here.
Thank you, John. First of all, thank you for having me. This was a real pleasure to chat with you as well. I just wanted to highlight a couple of resources I'm kind of highlighting here. If you want to try Vectara, you can sign up to our account here. There's the documentation of the API if you need more information. And I'm on our Discord server, so if you want to join that and you have other questions, you could direct message me there. I spend a lot of my time there, so I'm always available. And also, we have this initiative where this QR code, if you click on this, you can actually schedule time with me. If you have, we call it untangler RAG, because we find a lot of people who start doing it yourself without our platform, find after a few months that it's just very complicated and tangled exercise. So this is a link for you to reach out to me as well in a different area and maybe schedule a call. And I'm happy to help everybody who has questions and anything like that. You can of course link to me here, and I hope you try Vectara-agentic with Vectara. And again, happy to help in any way I can. And thanks for listening.
Thank you, everybody. Try out Vectara-agentic. Thank you for joining, and we'll see you guys in the next one. Take care.
All
Bye,
right.
everybody.
Thanks.